Hello everyone, welcome to the Mammothon tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Programme Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the programme, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
I am Ryan. I am a co-founder at Prism. I worked as a Celestia core protocol engineer for about 2 years on the Celestia node team before I left to make this company. And this is a very new project. It's been fun. We're excited for this hackathon to get some people in and starting to build. Yeah, I'll just start to share. Hold on. All right. So for some context, this is not going to be a super technical talk because, first of all, I assume you guys are competent engineers. And also, I don't think that anything I say here will really be retained well. But I will give kind of like an intro to what Prism is, what we're doing, why it's important, and the 2 ideas that we came up with for you guys to build. There's going to be a lot of creative freedom around it, but will help a lot, of course, guiding in how you can actually build these things out. And yeah. So first of all, I made a little QR code. I will have this again at the end of the slide, so don't freak out trying to scan it. But if you're interested in building any of these ideas, it would probably be good to join this group because our docs are shit so far. In fact, the tutorial I made today for these things isn't even up yet because we're having deployment issues. It'll be up probably within a few hours. But anyways, you'll probably have to ask questions to us directly. You'll definitely have to ask questions to us directly, and we'll kind of figure this out together, improve our DevX, which is like very early alpha, of course. Yeah. By the way, I cannot see any questions. So if any questions come up, put them in the chat. I'll save some like time, maybe 10 minutes near the end to go over them, but I won't be able to answer them live. So anyways, what is Prism? So there's this thing called end-to-end encryption, which I'm sure everybody knows about. It's how you talk on messaging apps and it's also how you communicate with servers when you're browsing. There's that like little lock icon that tells you that you're browsing securely, but you're not actually safe, and you're not actually as protected as you think when you're messaging using these messaging apps, including Signal. In fact, Signal is the worst contender among apps that are end-to-end encrypted in terms of having no key transparency. What do I mean by that? Key transparency is an area of research that is specifically focused on enhancing the security and trustworthiness of end-to-end encrypted messaging. What I mean by that, I'll get into, but basically these services, like, to have a concrete example, you can think of Signal. They have something called a key directory. It's like, okay, I want to talk to Lazarus. So I'm going to ask Signal, hey, tell me what Lazarus's public key is so that we can do a key exchange, so that we can talk end-to-end encrypted. But I don't actually know if that key directory is giving me Lazarus's key. Like, there's nothing that can tell me, like, this is Lazarus. They can simply put their own key in there and then just forward the messages, and you would have no way of knowing that they're not only reading your messages, but they would have the possibility to modify them as well. So users are trusting these centralized servers to authenticate each other, and they can't verify they're communicating with the intended person unless they meet up with them in real life. I'll show why. There's like a little security feature in most of these apps called security numbers. And for it to work, you need to have a trusted third channel, and the only real trusted third channel is real life. So yeah, I will show you kind of in the graph what I mean here when I say man in the middle attack. I don't know how much time I'm going to spend on this. Also, it could be that I'm done very early. We'll see. So I might be able to let you guys go early. So Bob wants to talk to Alice over a chat app. So Bob requests Alice's public key from the key directory of the chat app. So like Signal's key service. That key directory gives me Alice's public key. Bob then encrypts a message with that key, sends it to Alice. Now, in reality, it's not this simple, and this is very dumbed down, especially in regards to like there being the triple Diffie-Hellman key shake, and then the double ratchet mechanism for actually encrypting the messages. But the attack still works. So I send the message to Alice. The message service can then forward that message to Alice. Now, the message service at this point, if this is a trustworthy service, cannot actually unencrypt that message. It doesn't have Alice's private key. So they just forward it to Alice, then Alice can decrypt that message and see the contents. So what happens with a man in the middle attack is that what actually happens is that, I put this diagram a little bit. It should say return PK Mallory. So Bob requests Alice's public key, and then key directory gives me Mallory's public key. Now Mallory in cryptography, that's like a malicious actor. It could be a state level actor, or it could be the service itself, whatever. Like this could be a backdoor for the NSA or whatever. And so then I encrypt my message with Mallory's key because that's what I got told is the identity of Alice. But because this backdoor, they have the private key for that, they can simply decrypt the message I sent them, then encrypt it with Alice's real public key and send it to Alice. So that's a huge problem. What do these apps actually do to solve it, right? Like, there's no way that this is such a huge issue and they haven't done anything. But they haven't. So on the left, we have Signal. In the middle, we have WhatsApp. And on the right, we have iMessage. Now, iMessage is actually the best out of these so far in terms of key transparency. They actually have something called contact key verification, but it's off by default, and you have to go through an annoying setup to get it working. The other two, they just have these privacy numbers. So the reality is that nobody is actually ever really using these. Like I've met 1 or 2 people that actually use these, and nobody has an idea that you need to do this. Like you could be talking with whoever. But anyways, yeah, it's a huge privacy problem. So of course, in order to talk to someone over the internet, shouldn't need to verify these security numbers first in real life. Yeah, and this is not just with messaging. It's like when browsing, we have the same problem. There's these like middlemen in form of a key directory or a transparency log that really make things very opaque. Like they're not transparent at all, and we can't verify anything by ourselves. So what we want to do is move the internet from don't be evil, which is Google's old motto, don't be evil, to can't be evil. So Prism's construction architecture uses the key transparency research out of the last like decade. And with Celestia, a lot of the ideas that have been sitting around latent in those papers has become possible. So we've implemented it. But the goal is to over those middlemen, to take back the internet really, to restore the original ideals behind it, to give users control back, and be able to verify directly without having to trust these third parties. So we made Prism, very short overview. It's a base to roll up on Celestia. We group, instead of blocks, we create epochs, and it generates a ZK proof over everything that's happened in that epoch. We publish that proof to Celestia, and then our WASM light node, which is also live, by the way. If you go to prism.rs, you can run a Prism light node in your browser. It doesn't work on Safari right now because we're having some deployment issues, but it should work on the other browsers. You can integrate that directly into applications like, for example, a chat app. And then what that's doing in the background is it's able to verify this ZK proof that everything that happened inside of this key directory is valid. Now, in a sense, that is kicking the can down the road of, okay, well, then you need to be able to ensure that when a user creates an account, that creation is done validly. Because if we know that retrieval is directly verified, like, okay, I'm requesting Alice, I get Alice, then the question still remains, how did Alice get added? How can I know that that's really Alice? And so that's something that one of the project ideas goes into, but it's also discussed a little bit in our docs, and very happy to go into discussions for how we solve that problem later. But what's really, really cool about it is that it enables this direct automatic authentication of services without relying on an RPC. So like in old Ethereum days, like at the beginning of Ethereum, this is what we had. We had Mist browser, and you would go visit an app, and it was like your browser was actually running a node, and you were able to directly verify it. Now, when you go visit something using Ethereum, it's like, oh, it connects through MetaMask or whatever, or via a gateway that's just talking to a full node. So they're like, the trust assumptions are not better. And this is like the most common criticism, technical criticism of people outside of crypto coming into the industry. It's a huge problem. We want to solve it. We already made a lot of headway. And yeah, it's not only about messaging. So the entire internet runs on this type of protocol. And the only solution we really have up until now has been shipping with a hard-coded list of these certificate authorities, which is actually insane. And it's been attacked very often. Like Microsoft has like an insane amount of certificate authorities that come shipped with their browsers and devices that nobody else has. Lenovo had a notorious hack. Like DigiNodar had one. And I actually personally think, and I know this is going on a tangent a little bit, that the certificate transparency issue is a much bigger one than the key transparency issue. And that's because browsing is something that we have proof that it has been attacked many times throughout its existence, and that users were not able to see the attack and they've been compromised. Whereas with key transparency, it's like kind of theoretical, like, okay, Signal and WhatsApp and all these services, they could be spying on you and the NSA could have a backdoor and you wouldn't really know, but we don't have proof of that ever happening yet. So like, although we can prevent that, I don't think it's like a very present fear in people's minds. But I guess even with certificate transparency, it's not a huge fear that's present in people's minds because people don't know how bad it is. Like, they see the lock, they think they're safe, but they're not at all. And I made a Twitter thread that goes into that as well. I can post it in that Telegram group later after this talk. And yeah, excited to talk about it. So Prism unlocks a lot of things. Of course, we have that like authenticated end-to-end encrypted messaging and file sharing. The next two ideas are what we have for the hackathon. So monitoring and verifying certificate authorities' behavior by running the light node. And this is really cool because it's a browser extension that protects you in a way that nothing else in the history of the internet has been able to do. Like, no VPN can do this for you. Nothing is actually doing this. If you were to write a ton of code and you had a really beefy computer and you made your browser, then sure, you have that level of protection. But like, I think that this browser extension, if you actually go build this, you can build a whole business around this, because people that are really conscious about their privacy are going to need it and want it while on the internet. Like, the attack vector for certificate transparency is, let's say you want to go to Twitter. So you type in twitter.com. Now your government, and this attack happens all the time, is investigating you. So they decide to use a fake certificate. So they collude with the certificate authority and the log operators to give you a certificate that has not actually been logged. So your browser says everything is fine, it's signed by a certificate authority, but your browser doesn't actually check that it's been included in the log. So you think you're talking to Twitter, but you're actually talking to your private your personal investigator, and you, without ever having to go to Twitter, these states can then it doesn't even have to be your government, it could be like the US government spying on you, can see all of your Twitter requests and all of your DMs in plain text, any API request, unencrypted. And that applies to any website you go to. So I think it's a huge problem that this is the first time that you can actually go build something extremely useful in a hackathon, build a business around it if you want, and hopefully win some money. But like, this is something that's never been done before, so it's cool. And then identity proofs, that's like, okay, so Keybase does this. If you guys know Keybase, it's like you can go link all of your different social profiles and say, hey, this is my key set, and this is my identity, here are all of my accounts. Imagine if you had that integrated into a chat app, or imagine that when you go into the chat app and you sign up with your Twitter, you can instantly see all your Twitter contacts there if you want. Or you like discover your social graph from other websites. You can bring your identity with you to other services. Now, this is something that's like a bit more abstract and requires thinking about Prism a lot more, and I wouldn't really be able to like go over it well in such a short presentation. But if it's something that interests you, again, please come talk to us. Come learn more. We're excited about it. The rest of the things I'll go into shortly because they're also cool. And if you're still interested after the hackathon, then you can make businesses around these things. These are things that would actually be pretty easy businesses to make that don't require a ton of code that nobody else can do right now. One of those is a key store rollup. This is something that we wanted to do internally, but we don't really have the resources or time to do it right now. It's something that everybody on crypto Twitter is talking about. It's kind of like the new meta for like wallet UX, and you can actually make a cross ecosystem key store rollup. What we realized is that Prism literally is a key store rollup. You just need to write the smart contracts around it and like find out a few other side of the business details, and then it works. Peer-to-peer VPNs. Now, this is something that NIM is actually already doing, and I love NIM, and we'll probably also use them in our own P2P stack. But like an issue with making P2P VPNs nowadays is that you can't verify the authenticity of that connection. And with Prism, you can make a P2P VPN. I don't know, pretty easy sell. You can make private rollups, or Henry from Penumbra did a very, very good talk at Modular Summit. You can go find it, called Dark Rollups. And it's a whole new design space of things you can make on Celestia. If you were to use Prism kind of like a nullifier tree in ZK. You can make a password manager that it's like has verifiable password sharing, so you don't have to worry when you share passwords and stuff. Now the last one is kind of an old idea, and I think like there's not really a future where that can play out well because it's too ingrained in the actual hardware. But technically, you could reduce TE trust assumptions by decentralizing the Intel attestation service. Like right now, when you use a TE, the trust assumption is, I mean, one of them is that this Intel attestation service, you request, say, hey, is this valid? And they're like, yep. But you could kind of get around that if you were to use Prism. So anyways, I'll get into the ideas now, sorry. So first one, certificate transparency browser extension. Browsing end-to-end encryption is just as problematic as messaging. So this project unlocks a whole new layer of protection when browsing. This is something that we have built a prototype for internally. We know it works. We know really well how to help. So yeah, what it would be is like two parts. So there's a service, a Rust service running in the background. And this would monitor the CT logs. And so there's a crate available that can do this monitoring for the CT logs very easily, and it's nice to use. And it would create Prism accounts for every transparency log and keep them updated. So like this service that you would write in Rust, and the tutorial I have is how to make a Prism service, would go monitor the CT logs, and then keep accounts on Prism updated with the latest like root of that CT log. Now, there's a lot of technical aspects to certificate transparency that I'm not going to get into because it's out of scope. I have some diagrams on our website, or will, I guess, in a few hours because it's not up yet. I'll show it maybe after this because I'm going to have a lot of time left. And then the second part of it would be this browser extension. So the browser extension, I recommend starting on Firefox because I think the APIs are easier for retrieving the certificate data. But simply like, look, okay, what website is this user on? Let me see that certificate information. Then inside the certificate information, you can see what logs it should be posted to. And you can ask Prism, hey, go give me those accounts. And then Prism goes and gets you those accounts. And then you can verify simply through that with a Merkle proof that those certificates have been included in the append-only tree of the logs. And that's like, that will help you get around the attack. Because if it's in there, then you can also prove that it's there maliciously. And typically when things do get included in the logs, they do get noticed if they shouldn't be there. It's only really a problem when certificates are issued that do not actually get included in the logs because your browser isn't checking for that. But it would be like a super simple UI, like Prism service, that's just backend. That's like, I don't know, probably a few hundred lines of Rust. That's like, a lot of it will be our own boilerplate, will help you there. And then the browser extension would just be like a little pop-up that shows you, okay, we have successfully gotten the accounts from Prism and they've been validated, you are safe. Maybe it would show like an icon in like the toolbar or something to make sure. But that would be like super simple UI. So if you don't really like front end stuff, this is the better choice. So I have here like the Rust CT client crate is very good for working with these certificate transparency data structures and logs. We have a tutorial for how to create a Prism service. And that link is, like I said, isn't going to work right now. I'll try to have it up in a few hours. Join the Telegram group if you have questions. And then we have the certificate transparency service outline, which is like, has a few more diagrams for how this will end up looking like, and should help you get up to speed with kind of the requirements. Which again, there is very little technical oversight in how you decide to do things. We just like show you, okay, this is kind of how we see it working. This is like the minimum viable necessary. Now go make it. These are very simple ideas to create, or like simple being, it's definitely in scope for Hackathon, but they're really powerful, and that's why we chose them. So idea number 2, every time you sign up for a new website, your network is starting from 0. Like if I want my friend to go sign up to Twitter, they're going to sign up for Twitter, not have anybody to follow. They don't know where their contacts are, blah, blah, blah. Now, most apps then like integrate some sort of, oh, connect your phone number, and then you can see all your contacts. But that doesn't give you any control over anything, and most of my friends hate doing that. It'd be really cool if when I joined Twitter, I could be like, I want to bring in my network from GitHub and whatever, and this social network and stuff. So that's kind of what we're going to do with the chat app, where it's like, okay, here is a proof that I am this person on Twitter, that I am this person on GitHub, and then next time that somebody gets a scam message from me, they can simply go to my profile and be like, this isn't him. Like he doesn't have his GitHub or Twitter or anything linked, and he has like no reputation from the system. So we wanted to offer the like initial iteration of what that could look like, and that is using Reclaim protocol. So this project would, number 1, this is more of a front end thing, I think. You'd have a front end that allows the user to like sign into some social media, maybe Twitter, maybe whatever you want. It doesn't really matter, whatever social media. And it would create a proof using this Reclaim protocol. Now, from my understanding, Reclaim proofs are just a signature by the notary. And then you'd also create this Rust Prism service that takes these Reclaim proofs and adds them to Prism accounts. Now, I know that without the context of actually using this framework, it's like pretty abstract. If you're actually interested, then anything I say here isn't going to stick anyways, so I'm not going to. But this Rust service will probably be the more difficult part. And then the front end, I think that Reclaim has really good docs, and our problem is that we don't yet, and that you guys are going to help us figure out how to make our API good and improve our developer experience, because this is so new. Anyways, this Prism service would basically take requests with the Reclaim proof and then let users create accounts for it or add it to their account, because we have an operation called add data that adds it to their account. So this is Reclaim protocol. Then there is the Prism service tutorial. Then there's the like Reclaim project outline that I'd added. And both of these projects use mainly Rust and then TypeScript or JavaScript. So I think that the technical complexity of these have little to do with programming and more to do with like deep diving into how protocols work. In the case of certificate transparency, you get to deep dive into certificate transparency, and the programming is maybe not that exciting or intense because there's not a ton to do, but the actual like impacts of it and what it means and really having a deep understanding of what it's doing is extremely helpful and fun and exciting. And it's the same for Reclaim protocol. Like being able to take a MPC, or not MPC, sorry, like a ZK TLS proof and doing something with it, bringing it on chain is very fun, very exciting. And Prism itself, I hope at least, is exciting and interesting to people. I think it's a huge paradigm shift in apps that we can create. We can make them verifiable, and yeah. So again, here is a link to a Telegram group. I'm going to leave it up for maybe a few minutes, or I don't know, maybe, wait, hold on, let me X out of that, and then I can actually start to see questions if there are any. Prism documentation hasn't been, wait, I think there are only 2 questions, okay. Oh wait, 1 question, including Telegram. Telegram is not end-to-end encrypted at all. Telegram is the worst possible. So Telegram has absolutely 0 end-to-end encryption, and it doesn't even have the problem of being able to be man-in-the-middle attack, because they can just read your chats directly if they want. Where is Docs Prism? Docs Prism is at docs.prism.rs, but it's not updated yet. So there are a few pages for the Mammothon that are like done, but their build system is not working because I guess we're bad programmers. But I will show you them locally first, maybe. So 1 sec. So wait a minute, where is it? Is it there or there? Sort of. Okay. So arc tab. No problem, Huck. Sorry. All right. So I have docs technically. Like, hold up, I have a tab here with some stuff, but and I'm zoomed in like crazy, of course. So sorry about that. But so here, this is like the basic service tutorial. This is for Rust. We don't have any tutorials for the TypeScript stuff. If you're interested, come to our Telegram group. But basically, you can go to our starter template and create a new project, install the dependencies, and then this walks through the code for setting things up for DevNet pretty in-depth via the comments. What happens registering service, what that means to register a service, because we have like what is an account on Prism, what is a service, things like that. I linked all of that stuff. Registering the service, creating accounts from it, and then adding keys to accounts, adding data to accounts. That's all you really need for the 2 ideas that we have. And then for the actual like certificate transparency browser extension, I have a little bit of like some diagrams here that I'm not going to really pause on. But there are like, okay, this is kind of the flow of things. That's how it looks. And then in terms of the web proofs, if someone is interested in this, I will absolutely add more. But I basically just have here what I have in the slides, and then a link to the Reclaim protocol. So one other thing that I will share is that I mentioned that we have light nodes in the browser, and what that means I want to show. So if you go to our website, prism.rs, you'll see don't trust, verify. It's a new verifiable. Let me zoom in, sorry. You can run a light node in the browser. The zoom is kind of messing it up, I think. Wait, what happened? Hold up. So this is our blockchain node running in the browser, and this could be inside of an app, inside of a browser extension. But this is like our Prism code verifying the key directory, verifying that accounts have been constructed correctly, that are according to your rules that you put in your service. You simply get to verify this little ZK proof, and then you're sure that all the contents of it are correct. So it syncs pretty quickly. This is running on our DevNet. We are in the process this week of making documentation for how to connect to our DevNet, because we're like moving very fast. But anyways, so I guess to sum it up, if you guys want to build something actually really useful this hackathon and possibly make a business out of it, I would love if you came and worked on our project ideas, and we would love to guide you and possibly talk about grants afterwards to continue on them. And it doesn't only have to be those two ideas, of course, but anything you guys are interested in building, this unlocks quite a lot. We're excited to have you. Yeah, is there any more questions?
We do actually have one question in the questions tab,
Yeah.
from LZRS asking, did you ever reveal the meaning behind the name Prism? They have a guess, but we'd like to know what the meaning of the name is.
Yeah, so the meaning behind the name is that Edward Snowden in 2013 or 14 whistle blew information from the NSA that is Prism. So this whole system of mass surveillance that the US was constructing, was called Prism. All right, wait, that's our GitHub. And so we decided, out of spite, because the NSA, to call it Prism. And so Prism is this actually global surveillance thing that puts backdoors all over the world, so that the American government can read your chats and internet traffic everywhere. And we said, screw that, let's just call it Prism to for the contrast. I mean, there are other good reasons, like, okay, well, it's a prism, so light is shining through and it's like illuminating the transparency of these systems. But this is the main reason. It's like, I don't put the
LZRS's guess was it had something to do with light nodes and separating wavelengths.
Oh, I mean, no, that would be cool. I guess I might start saying that too, but it has more to do with the NSA.
That's great. Do we have any other last minute questions? We've got the links to the docs.
I will say one thing, and that is, I'm just realizing I did speak very quickly and flew over a lot of things. So don't be intimidated. I think that the best way to really communicate with us isn't going to be this presentation anyways. It'd be to come talk to me on Telegram. So feel free. I'm excited for any interest. Yeah, thank you everybody who stuck around.
Okay, thank you for that tutorial, and also thank you to LZRS for this Chopin tutorial earlier. We'll end there for today, and we'll see some of you again tomorrow for our next 2 tutorials. Have a good rest of your day, everyone, and good night if you're in some of the later regions.
Thank you, everybody. Have a good night.